All right, this is the study guide for Algebra 2, Unit 6, Real Numbers. So we're going to talk about these problems real quick. The first section of this study guide is all true and false problems. So the first one says the conjugate of 8 minus square roots of 3 is 8 plus square roots of 3. Okay, so just remember the conjugate, it's a binomial. It's when you have a binomial with a radical in the denominator. And yes, it's just, if it's positive, it has to be negative. If it's negative, it has to be positive. Just change the sign in the middle. So that would be true. Number 2, they want to know, if you multiply cube roots of negative 3 times cube roots of negative 5, does it equal cube roots of positive 15? So remember, as long as they have the same root, then you can multiply them. If that's at square root times, if that's at square root times cube root, if this had a 4 here and a 3 here, you can't multiply them. But because they have the same root, you can. So yes, and then two negatives make a positive. And then they say on number 4, ignore number 3. It was removed from the test. And I just didn't have time to remake the study guide today. On number 4, it says the square root of x equals negative 7. Okay, immediately we should know this is impossible. Anytime the square root cannot be a negative number. Okay, square roots cannot equal negative numbers. It's impossible. No, sorry. The square root, it can equal negative 7 because negative 7 times negative, because negative 7 times negative 7 equals 49. But when you, then they say that means x equals negative 49, and that's not true because you can't have a negative in here, okay? So the whole negatives with square roots, you just don't see them, all right? And then problem number 5. They say, let me erase these real quick. Number 5, they say, if x plus 2 squared equals 49, then this equals x plus 2 and 7. Okay, so this is referring to the square root method, okay? So when you have a quadratic that looks like this, you can solve it by doing the square root method. But remember, on the right side, you always get a plus or minus sign, all right? So this is incorrect because it should say plus or minus 7 right there. Okay, on problem number 6, they say you have x squared minus 6x plus 8. And they want to know if this can factor to x minus 4 and x minus 2. Okay, they want, because this would be solving by factoring. Solving by factoring, you just factor. So your factors of x squared are x and x. And then your factors of 8 are 4 and 2. And this would give you negative 2 minus 4 would give you a negative 6. And in the end, you'd get a positive 8. So yes, that does factor correctly to what they say. Number 7, they say in the process of completing the square, 3x squared plus 7x minus 12 becomes this other thing. All right, so remember, in completing the square, the first step is to take this coefficient and divide both of these by the quadratic coefficient, all right? So this would actually end up being x squared plus 7 over 3x equals, you would move it 4, because 12 divided by 3 is 4. But in the option they give you, they have a 4 right here, all right? You're not dividing by 4, you're dividing by 3. So no, that should not be true. In number 8, they ask if this quadratic formula is true. They say x equals b plus or minus b squared minus 4 times a times c over 2a. That is incorrect, all right, because they are missing the negative sign in front of the b, all right, because the quadratic equation is negative b. plus or minus the square root of b squared minus 4 times a times c over 2 times a. All right, so that is incorrect. On number 9, they say b squared minus 4 times a times c is greater than 0 means the root is real. Okay, so that's when we're dealing with the discriminant. So we had a whole lesson about the discriminant. The discriminant is this part of the equation right here. B squared minus 4 times a times c. This is the part that is the root of the problem. So if it is greater than 0, then it is real. If it's less than 0, that's when you have an imaginary number. So this is true. If this is greater than 0, if b squared minus 4 times a is greater than 0, then that equals a real root. All right? And then number 10 is I to the 4th equal to 1? You'll have to look that one up. They give you a chart, so just read your chart and see what it says. All right, on number 12, they ask you to write this fifth roots of x to the power of 3 using a fractional exponent. So remember, a fractional exponent is pretty self-explanatory. It's an exponent. That's a fraction, all right? So in your fractional exponent, the numerator is the power and the denominator is the root. So this is x to the power of 3. So your numerator is going to be 3 and the root of 5. So that number is going to go on bottom, all right? Number 13, they want you to rationalize the denominators. Okay, so in a denominator, you can't have a square root, all right? It's called a radical. You can't have a radical in the denominator. And this has a binomial. So to rationalize this, we have to multiply by the conjugate. All right, so the conjugate of this problem will be 3 square roots of 3 plus 2 square roots of 2, all right? So when we do that, we're going to multiply by 3 square roots of 3 plus 2 square roots of 2. We have to multiply on top and on bottom, all right? All right, so we're going to do FOIL method. You'll have to do, because this is a binomial, that's a binomial. We'll have to do FOIL method on top and on bottom. All right, so on top, we're going to have, first off, 2 square roots of 3 times 3 square roots of 3. So that gives us 6 square roots of 9, right? 3 times 3 is 9. Outer, 2 square roots of 3 times 2 square roots of 3 is going to give us 4 square roots of, so it's because I wrote that wrong. I'm like, that's not right. That should be a 2. All right, 2 square roots of 3 times 2 square roots of 2 gives you 4 square roots of 6, all right? Inner gives you 5 square roots of 2 times 3 square roots of 3 gives you 15 square roots of 6. And last is 5 square roots of 2 times 2 square roots of 2, which gives you 10 square roots of 4. All right, that's the top. The bottom, on the bottom, this is the difference of 2 squares. They're exactly the same, but one has a negative and one has a positive. What that does is eliminate the middle 2 terms. So we don't even have to worry about doing outer or inner. We just have to multiply the first terms and the last terms, all right? So the first terms is 3 square roots of 3 times 3 square roots of 3, which give you 9 square roots of 9. And last, 2 square roots of 2 times 2 square roots of 2, and one's negative, one's positive, so it's going to be negative 4 square roots of 4. All right, so let's look at our square roots real quick. The square root of 9 is 3. So this is actually going to be 6 times 3, which is 18. All right, so we can forget all that. Square roots of 4 is 2, which means 10 times 2 is 20. All right, so we can combine all our terms. Oh, this one down here, 9. Square roots of 9 is 3. Right, so this is 9 times 3, which is 27. Oop, that's a 4, not a 7. All right, and 4 times square root of 4, which is 2, gives you 8. So 27 minus 8. All right, we'll erase this top part and keep going here. It's a long problem. All right, so what we have left is 18 plus 20, right? Those are our like terms, which gives us 38. All right, then we have 4 square roots of 6 plus 15 square roots of 6. All right, because they're like terms, you can add them. 4 and 15 is 19 square roots of 6. And then on bottom, all we have is 27 minus 8, which is going to be 19. Now, you have three constants here. You have 38, 19, and 19. As long as all three of these numbers can be reduced by the same number, then you can do that, all right? And 19 times 2 is 38. So that means 19 and 19, and then 38. 19 goes into 38 twice. So all that's left is 2 plus square roots of 6. That's going to be the final answer. All right, we'll just do problem number 14. Problem number 14, they ask you to find real if. They want you to solve this equation. Number 14. So we know this is a quadratic because it has a radical. All right, so a quadratic is either going to have a squared or a radical symbol. So that kind of tells you. And we got to solve this. All right, so the best way to get rid of a square root is to square it. But if you square this side, you got to square this side, all right? So we're going to square both sides. When you square square root, you get itself. So just x minus 2. But on this one, that means x minus 8 squared. That means we're going to have to go x minus 8 times x minus 8 and do FOIL method on them, all right? So x times x is, this is going to say equal x squared. And we're going to get a negative 8x. That's outer. Inner, we're going to get another negative 8x. And last, negative 8 times negative 8 is a positive 64. All right, so we have x minus 2 equals x squared minus 16x plus 64. All right? So then put everything on one side. We have x squared. This x is going to move over here. It's positive, so on this side it's going to subtract. So negative 16 minus 1 is negative 17x. And then 64, and this 2 is going to add. So it's going to be plus 66. All right, so now we have a quadratic equation. This is the quadratic term, linear term, and the constant term, all right? So we can choose any way to solve it. You learn the square root method, the completing the square and the quadratic formula, also factoring. All right, this one actually I think will be pretty simple to do it factoring because your factors of 66 are 1 and 66, 2 and 33, and 6 and 11. And 6 and 11 will add or subtract to 17. 11 plus 6 is 17, all right? So we can just factor this to two binomials. The factors of x squared are x and x, they go here. And then we know it's going to be an 11 and a 6, and it's negative positive, so that means they're both going to be negative. All right, so to solve this, you just go, now that means x minus 6 equals 0, and x minus 11 equals 0. So x equals 6, and x equals 11. Now, we have to put the 6 and 11 back into this equation to see if it really works, all right? So you have to do this when you solve these. If it does not work, it is called an extraneous root, all right? So we got to try both of them, make sure both of them are legit answers. So it was 6 and 11. So we'll start with 11. So where x is at, we're going to put 11. So this is going to say square root of 11 minus 2 is equal to 11 minus 8. So 11 minus 2 is 9, and square root of 9 is 3, and 11 minus 8 is 3. So 11 is the correct answer for this problem. The other choice was 6. So we're going to do that. Square root of 6 minus 2 is equal to 6 minus 8. So 6 minus 2 is 4. Square root of 4 equals 2. And 6 minus 8 is negative 2. So these do not answer. So the answers in here will be x is 11 is the answer. X equals 11. And then 6 is an extraneous root. All right, problem number 15. They give us this quadratic equation, x minus 4 squared equals 36. So when you have something set up like this, you have a binomial squared equals a constant. The best way to solve is by using the square root method because the square root of anything squared is itself. So just square root both sides. Remember on the right side of the equation, it's going to be plus or minus, okay? So the square root of x minus 4 squared is just x minus 4. And the square root of 36 is 6, so it's plus or minus 6. Alright, so then to solve for x, you just move the 4 to the other side. It was negative, so over here it's going to be positive 4 plus or minus 6. So this is going to give us two answers, 4 plus 6 and 4 minus 6. 4 plus 6 is 10, 4 minus 6 is negative 2. And that problem is done. Number 16 is just another look at a type of quadratic. So this one is missing the linear term. As you can see, there's an x squared, and there's constants, but there's no linear term. So you can also use the square root method on these kind of problems. Put everything to all your like terms together. You're going to put your x squared, your quadratic terms on one side and your constants on the other. So we're going to leave this 2x squared here. This 2x squared is negative, so when it's going to add over here. Over here we have an 11, and then this 14 was negative, so it's going to add over here. So we're going to have it, my bad. 2 plus 2 is 4x squared equals 25. All right, so in this case, square root method works as well. Square root of this, square root of that, this side's going to be plus or minus. Square root of 4x squared is 2x, and the square root of 25 is plus or minus 5. So your two answers are going to be x equals plus or minus 5 over 2. So it means x equals 5 over 2, and x equals negative 5 over 2. Those are your two answers for that equation. All right, problem number 17. They say solve this equation. All right, so they give you a quadratic equation, 6x squared plus 11x minus 10, and they leave it wide open. You can solve it any way. On this one, you cannot solve by the square root method because you have your middle term. But you could use completing the square, factoring, or the quadratic formula. All right, so I'm going to choose a quadratic formula. I think it's pretty simple. So A in this equation is 6, B in this equation is 11, and C is negative 10. All right, so you just got to set up your quadratic equation. So negative B, right? The equation, we'll remind ourselves, negative B plus or minus the square root of B squared minus 4 times A times C over 2 times A. All right, so B is 11, so negative 11 plus or minus 11 squared minus 4 times A, which is 6, times C, which is negative 10, over 2 times A. Ooh, A. We know what A is. A is 6. 2 times 6. There we go. All right, so we have negative 11 plus or minus 11 squared is 121 minus 4 times 6 times 10. So actually it's a negative 4 times 6 times negative 10. So it's going to give you a positive, and then those three numbers multiplied are, that's 24, and then times 10 is 240. All right, over 12. All right, so then we'll add those two. 121 plus 240 is negative 11 plus or minus 361 over 12. Now 361, I think it is a perfect square root. Yes, it has a square root of 19. So you're going to say negative 11 plus or minus 19 over 12. So to get your two answers, you'll go negative 11 plus 19 and divide it by 12, and negative 11 minus 19 divided by 12. And if it's a fraction, leave it in fractional form. All right, number 18, they give us another equation. Leave it wide open for us to solve however we want. This one is not in general form, which is all together. So we have to do the multiplication. This is a proportion because it's a fraction equals fraction. So you can cross multiply to solve for it, all right? So that means you're going to multiply these two equals multiply those two, all right? That side easy. 4 times x is 4x. This side we'll have to do FOIL method on x plus 4 and x minus 2, all right? So FOIL method first, x times x is x squared. Outer negative 2 times x is negative 2x. Inner is 4 times x, 4x, and negative 8 at the end equals 4x. And then to put it in standard form, we need to combine all our like terms onto one side. So we have a negative 2 plus 4, which is a positive 2, but then we're going to subtract this 4. So essentially these cancel. And you're left with negative 2x minus 8 equals 0. All right, so there's our equation. Now it's in standard or general form, general quadratic form. So we need to solve it. Now there's no coefficient right here, so I'm pretty sure this will be pretty simple to solve by factoring, because your factors of 8 are 1 and 8 and 2 and 4, and 4 minus 2 is 2. So this should work. Your two binomials will be x, and then your 4 and a 2. And you want a negative 2, so that means you need a negative 4 plus the 2 equals 0. So x plus 2 equals 0, and x minus 4 equals 0. So x would equal negative 2, and x would equal positive 4. On number 19, they give you an equation. It's already in standard form, and they want you to solve by completing the square. 3x squared minus 4x equals negative 2. So it's not in general form, but it is in the form you need to complete the square. All right, so completing the square, first off, you don't want any coefficient here, so you're going to take this coefficient and divide both of the linear term and the constant term by that 3. All right, then you're going to take this middle term and times it by, divide by 2, which in fraction form is multiplied by 1/2. So you're going to go times 1/2 gives us 4 over 6, which we can reduce to 2/3, right? And then after you divide by 2, or multiply by 1/2 in this case, you square both of those terms, which would give us a 4 over 9. All right, so 4 over 9. We are going to add 4 over 9 to both sides of this equation. So now it's going to say x squared minus 4 over 3x plus 4 over 9 is equal to negative 2 over 3, also plus 4 over 9. All right, so this side, it automatically factors. That's why we do this. It factors to x, and it's minus plus, so it's going to be minus and the square root of this, which is 2 over 3. Right? So we've made our square. We have to add these, but to add fractions, you have to have a common denominator. So your common denominator here is 9. So we'll have to multiply this one by 3, and that means that by 3. So should give us a negative 6 over 9, and then add negative 6 plus 4 is negative 2 over 9. So equals negative 2 over 9. All right, and then the whole point of this is now you could use the square root method. So we're going to square root both sides. This side's going to be plus or minus. So the square root of x minus 2 over 3 squared is x minus 2 over 3. And the square root, negative 2, does not have a square root, but the square root of 9 is 3. All right, I wrote 9. Square root of 9 is 3. All right. And then because they have common denominators of 9, then you can just move this 2 over and combine it. So the x stays here equals, the 2 was negative, now it's going to be positive 2 plus or minus square roots of negative 2 over 3. Let me make some room here. So what we have here is an imaginary root, because we have a square root of negative 2. All right, so as immediately when we have that negative, we just bring it out, and that means it's I square root of 2 over 3. The end, all right? So that negative, you can't have a negative inside square roots, because anytime you multiply two numbers, whether negative or positive, it equals a positive. All right, number 20, this is actually our last quadratic to solve. They tell you to solve this one with the quadratic formula. All right, so it's not in standard general quadratic form yet. So we do have to do FOIL method on these two binomials. So x squared, we'll multiply them to x squared plus 3x plus 4x plus 6 equals 6. Combine our like terms, 2x squared plus 7x, and then the 6's are actually going to cancel because 6 minus 6 is nothing. So there it is. This is standard form, even though it's missing the constant. You can still run the quadratic formula. Your c, which is your constant term, is just going to be 0. All right, so a is 2 and b is 7, right? So negative b, which is negative 7, plus or minus square root of 7 squared, minus 4 times a, which is 2, times c, which is 0, over 2 times a, which is 2. All right, so it's negative 7 plus or minus square root of 7 is 49, and then 4 times 2 times 0, all of that cancels. So over 4. So the answer would, the square root of 49 is 7, so it's negative 7 plus or minus 7 over 4. So to get your two answers, the first one you go negative 7 plus 7 divided by 4 for the first answer, and negative 7 minus 7 divided by 4. All right, problems number 21 through 27 deal with the sum and the product of the roots. Don't worry about problems number 21 or 23 or 26. All right, those are gone. All right, but they want the first, number 22. They say use the equation and associated roots to perform the following exercises. And then they say negative b over a equals what? Well, they've given you an equation. Their 3x squared is the equation they're looking at. 3x squared plus 11x minus 4 equals 0. Okay, so this is the equation. They say what is equal to negative b over a. So just remember that a is your first term, right? So a is 3, b is 11, and c is negative 4. All right, so the first one they ask, what is negative a over b? And you're going to say b is 11, so negative 11 over c, which is negative 4. So it's actually positive 11 over 4. All right. Oh, I wrote that wrong. Sorry. They ask, my bad. They ask the sum of the roots, which is negative b over a. So it's negative 11 over 3. All right. And then on problem number 24, they say, so the sum of the roots is the same as, and you just have to put negative b over a. All right, and then the same thing for problem 25. They say, what is c over a equal to? Well, c over a is going to be negative 4 over 3. And then on 27, they say, so the product of the roots is the same as, and you're going to put c over a, because that's what it equals to. Problem number 28 is a fill in the blank. It says, use the discriminant and select whether the roots of this equation here, and select whether the roots of 5x squared minus 4x plus 3 equals 0 are real or imaginary. So remember, a real root is going to be a positive number, and an imaginary root is going to be a negative number. And all you have to work on is the discriminant. So remember, the discriminant is the square root portion of the quadratic formula, b squared minus 4 times a times c. So this determines whether this is a real or imaginary root. So b squared would be negative 4, doesn't matter, squared minus 4 times 5 times 3. So 4 squared is 16 minus 5 times 4 is 20, times 3 is 60. So 16 minus 60 is going to be a negative 44. So this is an imaginary. As soon as it's a negative number, you know this is an imaginary root. Right, then the last two problems, number 29 and 30, we're going to deal with our imaginary roots real quick. So they want you to multiply square roots of negative 15 divided by square roots of negative 4. Well, immediately we're going to take out our negatives, right? And they're going to be i's. So you're going to have I squared root of 15 times I squared root of 4. And then 4 is actually a perfect square root. So the square root of 4 is 2. So it's actually I squared root of 15 times 2I, right? And 2I times I is 2I squared, square root of 15. And then I squared is negative 1. So negative 1 times 2 is negative 2, square root of 15. And that's the end. Then number 30, they want you to rationalize the denominator again. You have an imaginary number, which you can't have in the denominator. So you've got to multiply by the conjugate, which is going to be 6 minus 5i. So we're going to multiply the top and the bottom by 6 minus 5i. All right, so we'll have to do FOIL method on top and bottom again. Let's erase this and do it up here. All right, so first is 18. Outer is 3 times negative 5i, so negative 15i. Inner is 6 times 2i, so that'd be 12i. And last is negative 2i times negative 5i, which is negative 10i squared. All right, and then the bottom, remember on the bottom when you multiply by the conjugate, you only have to do the first terms and the last terms because the middle two are going to eliminate. So 6 times 6 is 36, and then 5i times negative 5i is negative 25i squared. So remember, I squared, I just equals I. You can't do anything about that. But I squared is negative 1. So what it does is multiply this by negative 1. So it was negative 25, now it's going to be plus 25, and it was negative 10, now it's going to be plus 10. All right, so that's all that does. Now combine your like terms. You have 18 plus 10, which gives you a 28. Negative 15 plus 12 is a negative 3i. And then on bottom you have 36 plus 25. Add that, that's your bottom number. And that should be the end. All right, study hard, do your very best.